When I bought my first electric vehicle nearly 5 years ago, I wanted an EVSE that could charge it at 16 amps, and we chose the Charge Amps Ray. You might call this a charger or a charging cable, but EVSE is the industry term. It allows a user-selectable charging current of between 6 and 16 amps, and it has a nice long 7-meter cable, which is long enough to let us park behind another car if necessary, and still charge. And it has a unique design that's unlike any other EVSE I've seen. At least some of the electronics are in the J1772 plug, including a touchscreen which is used to set the charging current. Furthermore, the plug features a light, and the latch that keeps it in is electronically controlled, releasing when the plug senses the touch of one's hand. Unfortunately, it didn't stand the test of time. When it rained heavily, sometimes it would behave erratically, refusing to charge or even refusing to release the latch until it was power cycled. I should point out at this stage that this is a device designed for outdoor use, advertised as IP66, which means it's supposed to be able to handle powerful water jets from any direction. Rain shouldn't be a problem. One time the power cycle didn't cut it, and wondering if perhaps water was leaking in, I took out the screws in the plug end and pulled it open, and there was definitely water in there. At that point I probably should have returned it or thrown it out, but we don't always make good decisions. I dried it out and it gave us another couple of years of service, but when it finally died again there was no recovery. One morning the screen showed an unknown error and was unresponsive. After letting it thoroughly dry, it was totally dead, no display at all, and intriguingly the slim box near the plug, which I believe is referred to as an in-cord control and protection device or IC-CPD, was only partially illuminating the logo. Could it be damaged as well? Let's find out by pulling this thing apart. There's no chance we're going to use it again now, so we can be as destructive as necessary. I don't really know who the audience of this video is, but I hope at some point it will be useful to somebody. We'll start with the J1772 plug end. I've already removed the 3 screws. The clear plastic piece that holds the pins in can then just pull off. Now we can see the electromagnet that pulls back the latch. There's not really anything else we can do from the front of the plug. Now for the back of the plug, the bezel has to pop off, which is not easy. I tried using a plastic prying tool and eventually resorted to a screwdriver. It took a while, so I've sped it up a lot. Sorry that it's not all in frame. If I ever have to pull apart another EVSE, I'll do better, I promise. And there we go, that was a satisfying pop. Now we have to remove 4 Torx screws. You can see them a bit better in this still image. It looks pretty dirty up close. And then that top piece just pops off. We've got a main plug to undo and another one for the electromagnet. And we can see that apart from that it's just wires in there. Interestingly, the cable appears to be completely surrounded by the earth wire, which presumably provides additional protection if the cable is damaged. Now let's have a closer look at the circuit board. It's very hard to read the markings on the main IC here, but I can make out X Mega, which is a line of AVR microcontrollers. Now here's a fun part. I thought I'd plug it in one last time, very carefully, to show you what it does. You can see it light up a little, but then, well, that was interesting. It seems like it had some kind of short circuit or something, and something went pop in there. My actual reaction to that needed to be edited out. By the way, from this angle it kind of looks like the pins of the plug might have been touching, but they definitely weren't. So I'm taking apart that top piece now, which involves some more screws. That's freed up the circuit board, and now peeling off the tape doesn't reveal anything much more, just the little touchscreen. Now it's time to move on to the IC-CPD. This also required the removal of some Torx screws, but these ones are quite deep, which necessitated a trip to the electronics store to get a new screwdriver set. Okay, now let's open it up. Wow. It's not easy to see in the video footage, but I can immediately tell there is moisture in here too. So both main housings of electronics in this thing have let water in. We'll look at the board a bit more closely in a minute. Aside from that revelation, it seems most of the space is taken up by two chunky relays, one for the phase wire and one for neutral. Here's a closer look, and you can see the moisture quite clearly all over the place. Let's keep going. Now we can take a proper look at the back of the board. There's more moisture here, but also a few of the chips are looking very rough on top. It's hard to tell, but I'm guessing one of those chips might have blown up in that little incident earlier. It's also interesting to note that there is quite a lot of electronics in this part as well. Now finally, let's have a look inside the plug. It's a 16 amp rated plug, commonly referred to as a caravan plug or commando plug in New Zealand. And it's important to note that this is not the original plug. It was changed by the company that sold the product to me. The original plug looks like this. One might think the plug is too boring to even bother with, but my understanding is that there should be a temperature sensor inside. It certainly looks like the original plug had one, and I'm interested to see if there's one in the replacement plug. The temperature sensor's job is to slow or stop the charging if the pins of the plug get too hot. To get this one open just required poking a screwdriver in while twisting it. So I'm not seeing anything that looks like a temperature sensor in here, but there is a bit of heat shrink with something interesting inside. So we'll have a look at that. So it's a capacitor and a resistor connected between the ground and that other wire. And I'm not enough of an electrical engineer to know what that would be for, but there's definitely no temperature sensing going on. I can only guess it's either pretending to be a thermistor with a fixed dummy temperature reading, which is concerning, or is somehow related to ground fault detection. Well, that's basically it, except just in case you wanted to see that bit again. Thanks for watching.